Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to simplify rational expressions. This standard is covered in Algebra 1, 2, and Pre-Calc courses. Don't forget, we have 5 practice problems at the end of this presentation that we'd like you to try out in order for you to demonstrate mastery of what we covered in this presentation. If you haven't already done so, go ahead and subscribe to our channel, and also take a look at the links in the description below so that you can have access to our wide variety of tools to help you master algebra. Alrighty, the instructions for the examples that we're going to be working on are as follows. We are to simplify each rational expression, and then you're to do something else, okay? After simplifying, you're to state the constraint and state the constraints, because there are specific values that makes the output of the rational function undefined. Okay, so you have to explicitly state what the constraints are for the rational expression given. Okay. Number one, let's say we have the rational expression 45m squared plus 81m over 36m. Alright, so to do this, what we're going to do first is we're going to split it up. We're going to extract the numerator and the denominator, and we're going to factor them out completely. Well, why is that? We're doing that because we want to see what they have in common so that we can divide it out and then know what the simplified form is. Okay? Alright, so let's start with the numerator. Pull the numerator to the side. So the numerator that we have here is 45m squared plus 81m. So what do they have in common? We can clearly see that they have 9m in common. Okay, so we're going to factor that out. Now let's assume it's not obvious to you what the common factor is. So all you just do is you just basically break down each term. Okay, using the factor tree, if you break down the first term, you have 3 times 3, 9 times 5 times m, and then if you break down 81 is 3 times 3 times 3 times 3 times m. So what's common? We have 3 common, and then we have one m and another m common. So if we factor that out, so you factor it out and divide it out. Okay, so you factor out 3 times m, that's 9m. Okay, so factor it out, divide it out. The common factors, and then we're left with 5m plus 9. Alright, so if you've forgotten how to factor expressions, how to factor polynomial expressions, just take a look at our presentation in the link provided, and we will give a real quick refresher on how to factor expressions. Okay, alright, so that's that for the numerator. And then now we're going to shift our attention. Let's go ahead and look at the denominator. Alright, so the denominator is what? The denominator is easy to factor. What I'm going to do with the factorization of the denominator is I'm going to take out anything that I think is common with what I factored out from the top. Okay, so 36 m, I can factor it out into 9 times m times 4. Why did I do that? Oh, well, notice there's 9m from the numerator, so I might as well take out 9m from the denominator, so it's easy to factor out. Okay? Alright, so let me rewrite it in another way so it doesn't look confusing. So 9 times 4 is 36 times m. You can break it down all the way if you want. Okay? So notice the first step is to break down the factor, the numerator, and the denominator completely. Okay? Now, why did we do that? Well, check this out. Let's insert the factored state of the numerator and the denominator. And then what can we do now that we couldn't do before? We can clearly see what factors they have in common, and we can divide that out. Okay, 9 goes here 1, 9 goes here 1, m goes here 1, m goes here 1. So your simplified form is 5m plus 9 divided by 4. Okay, so the constraints or excluded values are as follows. So we now also have to state the constraints. So to get the constraints or excluded values, we're basically looking for when the denominator of the original is equal to 0. So the denominator can never be 0, because if the denominator is 0, you have an undefined output. Okay, so the denominator is 36m, so we're just going to set 36m to 36m cannot be 0. So we just solve this resulting equation, which was an inequality. So all you do is you divide both sides by what? We want to get m by itself, so we divide by 36. So the solution to this inequality is m can never be 0. If m is 0, then that value is undefined. Okay, so this is a simplified form, but we have to exclude m equals 0 from the solution set. Alrighty, let's try another example. Question number 2. Now for problem 2, what if we had the rational x squared minus 12x plus 27 divided by 9 minus x. Alright, so what we're going to do is exactly what we did with number 1. Alright, we're going to take the numerator and the denominator, and we're going to factor them out completely and put it back in and see if there's any factors in common that we can divide out. Okay? Alright, so let's start with the numerator. So for this one, the numerator is the quadratic expression x squared minus 12x plus 27. It's a quadratic trinomial, so we can factor this using the x game. Okay, so let's use the x game to factor that out. So AC is 27, B is negative 12. So what two numbers multiply to give you negative 27 and add to give you negative 12? It's 9 and 3. They both have to be negative. Alright, so since A is equal to 1, we skip grouping and we jump to the factored state, x minus 9 times x minus 3. Alright, so that's the factored state of the numerator. And then the denominator right here, I put 9, it's supposed to be 9 minus x. Why did I put 1? Fix that. Okay, so the denominator is 9 minus x. Okay, so let's go ahead and factor that one out. Okay, so the denominator is 9 minus x. So we notice we have x minus 9 here. So this is not written in standard form. So what we can do is we can rewrite it as negative x plus 9. And then I could factor out negative 1 because this x is positive. So I want to factor out this negative so it becomes positive. So when you factor out a negative, it becomes x minus 9. How did that happen? Anytime you divide a term by negative sign, the sign changes. So if you divide negative x by negative, it becomes positive x. If you divide positive 9 by negative, it becomes negative 9. So negative quantity x minus 9. Okay, so we have it factored out. Let's put it back together. So we will have x minus 9 times x minus 3 divided by the denominator, negative quantity x minus 9. And then what divides out here? The quantity x minus 9 both divide out. Okay, so you're left with x minus 3 over negative 1. Okay, so what you do here is you can divide both of them by negative 1, or you can just multiply the entire thing by negative 1. Okay, so you can just write it like this. It doesn't really matter. The sign can go anywhere you want it to go, either in the numerator or the denominator. As long as it's just one negative sign, you're fine. Distribute that through. You have negative x plus 3 as your final answer. Okay, so what's the constraint for this particular problem? To find the constraints, all we just have to do is make sure that the denominator is never equal to 0. So we take the denominator, which is 9 minus x, cannot be 0. So let's solve that equation. You add 9 to both sides. Sorry, you do the inverse, which is you subtract 9 from both sides. Okay, and then you have negative x cannot be negative 9. And then divide both sides of our inequality by negative 1. And we end up with x cannot be negative over negative is positive. You just slash in dash. Okay, so this is a simplified form, and we have to ensure that x cannot be 9. That's the constraint or the excluded value from our solution region. Alrighty, now we have 3 more problems to go through. Now that we've warmed up our brains, we're now going to step it up a little bit. We're going to go through these problems a little bit faster. So let's say we have m plus 6 divided by 3m plus 18. All right, so let's fly through this one right here. So what you do is you factor the numerator and the denominator. In the numerator, nothing can be factored out, but in the denominator, you could factor out a 3. And when you factor out a 3, you're left with m plus 6. Okay? So you see what's common in the numerator and the denominator is the quantity m plus 6. So you divide that out. And then your simplified form will be 1 over 3. Okay? And then what's your excluded values? So your constraint is as follows. The denominator, 3m plus 18, cannot be 0. Okay? So we subtract 18 from both sides. You get 3m is equal to negative 18. And then you divide by 3. And then you see that for this solution, m cannot be negative 6. Okay, so the simplified form is 1/3, and m cannot be negative 6. All right, let's take a look at number 4. So for problem 4, what if we have x plus 4 divided by the quadratic trinomial x squared minus 2x minus 24? All right, let's do this. We're gonna fly through this one also, since we're all warmed up, ready to go through them. So the numerator, as you can see, is prime. So I'll just do is extract the denominator. The denominator is x squared minus 2x minus 24. So for this one, we're gonna use the x game to factor it. So the AC is negative 24 and B is negative 2. The two numbers are multiplied to give you the top and add to give you the bottom is negative 6 and 4. So the factored state is x minus 6 times x plus 4. All right, we put that back in here. So we have in the numerator x plus 4, the prime linear binomial, times the denominator in factored state, x minus 6 times x plus 4. What do they have in common? X plus 4, divide that out. And you have your simplified form is 1 over x minus 6. Of course, we need to find what the constraints are. For that one, we're going to just basically set the denominator to 0. So for the constraints, the denominator cannot be 0. Okay, so x squared minus 2x minus 24 cannot be 0. How do you solve this? Well, we can just factor and use the zero product property. What is the factored state of x squared minus 2x minus 24? We already did it. It's quantity x minus 6 times x plus 4 equals 0. Okay? And then we set both of them to 0. X minus 6, x plus 4. Solve this, you add 6 to both sides, x equals 6. And then this one, you subtract 4 from both sides, x equals negative 4. So x cannot be 6, and x cannot be negative 4, all right? So for our simplified form, this is a simplified form, and x cannot be negative 6. I'm sorry, x cannot be 6, and x cannot be negative 4 because these are excluded from the domain of the solution set. All right, so that's the answer for question number 4. The constraint in question number 4 involves a lot of work, so well, it is what it is. Let's move on to number 5, the last one, and then we'll give you an opportunity to do some practice problems to demonstrate that you've mastered the art of simplifying rational expressions, okay? So let's say you have 30x divided by 15x squared plus 18x. All right, so let's go ahead and simplify this. Now, if you look at this expression right here, you notice that there's more work to do simplifying the denominator than simplifying the numerator. Okay, so I'm going to go ahead and factor the denominator first. So what can we take out from the denominator? Do you see what the greatest common factor is there? Greatest common factor is 3x. So you can pull out 3x from the denominator. Okay, and then you're left with 5x plus 6. Okay, and then just leave the numerator. Well, you can pull out 3 from the numerator since you now know what's going on there. So it's 3 times 10 times x. Okay, all right. So if this is not obvious to you, of course, you can break it down and then pull out common factors. Now let's divide what's common in the top and the bottom. 3 is common, divide that out. X is common, divide that out. So the simplified form for question number 5 is 10 over 5x plus 6. Okay? All right, so for this one, we also have to figure out what the constraints are for this particular problem since it's a rational. What are the unacceptable values for x? All right, so let's do that. To find out the constraints, what we're going to do, let's put it down here, is we're going to set the denominator. The denominator cannot be 0, okay? So the denominator, we're looking at the original denominator, 15x squared plus 18x. So this guy right here, that's the denominator. Not the simplified denominator, okay? So you gotta be careful. Make sure you are looking at the original denominator when looking for the constraints. How does this factor? Well, we already factored it before. It's 3x times 5x plus 6. This cannot be 0 because if it's 0, the function has an output that's divided by 0, which is undefined, okay? So both of them cannot be 0. So this one divided by 3, and then if you divide this by 3, the first constraint is x cannot be 0 over 3 is 0. And then for this one, you subtract 6 and divide by 5. Okay, you get negative 6 over 5 if you do the work. So you have x equal 5x equals negative 6, and then when you divide by 5, you get negative 6 over 5. Okay, x cannot be negative 6 over 5. So the solution to this problem is 10 over 5x plus 6 and what? And x cannot be 0, and x cannot be -6/5. Those are the constraints to question number 5. All right, it's now your turn to do some practice problems. So we have 5 practice problems we would like you to try out. So the instructions are the same as what we did in the practice problems. Simplify and state the constraints. Go ahead and pause this video presentation at this time and try out these 5 problems. When you're done, click on the play button and we'll show you what the answers are. Alrighty, welcome back. So hopefully you had a chance to try out the problems. Let's take a look at what the answers are. For the first one, the simplified form is 7x plus 8/5, and x cannot be 0. Number 7, simplified form is 1/x plus 5, and x cannot be -5, and x cannot be -2 also. For number 3, the simplified form is just 3, and x cannot be 7. For number 4, the simplified form is 1/x plus 9, and the constraint is x cannot be -9, and x cannot be -4. For number 5, the simplified form is 4x/x minus 3, and the and the constraint, so this is the simplified form. The constraint is x cannot be 3. All right, so how well did you do on this practice problems? Let us know in the comment section below how well you did. If there are any questions or any problems that you need further clarification on, just specify it in the comment section below, and we'll be more than glad to assist you. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your studies of rationals, do give us a thumbs up. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel for updates to future uploads. We upload videos to our page on a regular basis. If you have any questions or comments, as indicated earlier, just put it in the comment section below. And do check out our website at mathgotserved.com for tons of support resources to help you master algebra. Thanks again for watching, and have a wonderful day. Goodbye.